After sun formation, planets were formed. All planets are revolving around the sun. It is the fourth planet of our solar system, and we call it Mars. Mars is a rocky planet, and its size is about half the size of Earth. Around 4 billion years ago, Mars was like Earth. It had a watery past, with ancient river-valley networks, deltas and lake beds. It also had rocks and minerals on the surface that could only have formed in liquid water. But 500 million years later, it experienced huge floods. It also had protection like Earth, that protect from radiations. But due to time, its atmosphere disappeared into space, so the planet lost its magnetic field protection, and then the planet dried out. Mars have 2 moons, Phobos and Deimos. Its color is red, so we call it Red Planet. The Red Planet has actually many colors. At the surface, we can see colors such as brown, gold, and tan. The reason why Mars looks reddish is due to oxidation or rusting of iron in the rocks, soil, and dust of Mars. This dust gets kicked up into the atmosphere, and from a distance, makes the planet red. In 17th century, Galileo observed Mars with a primitive telescope, and became the first person to use it for astronomy purposes. After that, humans start thinking about planets. Since 1960, finally humanity has launched dozens of missions to Mars to learn more about our planetary neighbor. Since the first successful flyby in 1965, 5 space agencies have successfully made it to Mars: NASA, Soviet Union, European Space Agency, ISRO, and UAE Space Agency, while others, including the space agencies in Russia, Japan, and China, have attempted Mars or Martian moon missions without success. Humans send spacecraft to outer space for analyzing Mars. Unmanned spacecraft are basically 6 types. Number 1, flyby spacecraft. This spacecraft leaves the Earth and goes to its target side. Flyby reaches to the close of any object in the space. It observes that object, taking pictures, but never orbits that object. Number 2, orbiter. It is used for examine astronomy objects for a long time. If we compare it with flyby, then flyby speed is high, and it leaves that object, but the orbiter orbits around the object and studies its nature. It can study its seasonal activities and volcanic activities. It is mainly used to examine the detailed map of a planet or any other astronomy object. For example, Mariner 9. Number 3. Rover spacecraft. Rover spacecraft are electrical vehicles that are sent to solid astronomy objects. All tools exist in rover to examine the ground of that planet or moon. AI is used in rovers, so it solves problems by itself. It is used for examine chemicals, rocks, and other particles that exist in that planet, and everything is controlled by scientists. Curiosity rover on Mars is the best example of rovers. Number 4, lander. Landers are semi-automatic robots that land on planets, moons, and asteroids. It has no wheels, so it performs experiments in particular areas. Basically, landers study about the soil and atmosphere composition. Viking Mars lander is an example of a lander. Number 5, atmospheric spacecraft. Few spacecraft are used for limited time period operations that are used for examine the atmosphere properties, like atmosphere gases, density, how it changes according to pressure attitudes, how temperature varies. MAVEN is the example of atmosphere spacecraft. Number 6, penetrator spacecraft. It uses kinetic energy and hits on any planet, moon, and asteroid ground, and examines the underground chemicals. So these spacecraft give us the information about Mars. Humans have long fantasized about Mars exploration and colonization. That dream could become a reality now. NASA has plans to put astronauts on the red planet by 2030. But last year, SpaceX CEO Elon Musk, he is highly confident that the company will land humans on Mars in around 2026. Let's see who reaches first. But upon arrival, humans will have to overcome enormous obstacles to create a life on Mars. Mostly there are 4 problems. Number 1. Water locked in rocks. Water is essential to human life on Mars, but in Mars, there is no water. Almost all water is in the form of ice. Now there's no water in liquid form. Number 2, atmosphere. One of the most important attributes a planet needs to support human life is an atmosphere. Unfortunately, Mars made up of all the wrong gases. According to NASA, in planet Mars, carbon dioxide is around 95.3%, but in our Earth, it is less than 1%. Oxygen is the life of human beings, and by this gas humans breathe. In Earth it is 21%, but in Mars it's just 0.13%. Nitrogen is necessary for plants. In Earth it is 78%, but in Red Planet, it's just 2.7%. We'll have to wear oxygen masks and special suits every time, whenever they walk outside their sealed homes. Number 3, cold planet. Mars orbits the Sun at an average distance of 228 million kilometers. Air is also 100 times thin than our Earth. The thin atmosphere lets any heat from the Sun escape into space. As a result, Mars is very cold, so human visitors would find it very cold. According to NASA, Mars temperatures is around minus 285 degrees Fahrenheit. In summer, the average temperature is minus 63 degrees Celsius. It is similar to winters in Antarctica. The nights are also bitterly cold. Violent storms can whip up clouds of dust. Sometimes, these spread rapidly around the entire planet and hiding the surface from view. Number 4, high levels of radiation. Harmful radiation permeates the cosmos. Our Sun and other stars are essentially fusion reactors that spew abundant amounts of electromagnetic energy, including X-ray and ultraviolet radiation. The Sun, as well as other intensively energetic objects, like quasars, or the center of galaxies, also emit high-energy protons, atomic nuclei, and other particles that can cause radiation sickness, adversely affect a person's central nervous system, increase one's lifetime risk for cancer, and cause degenerative diseases. Our planet's strong magnetic field forms an invisible barrier against such radiation, and diverts most of these electrically charged atomic fragments back into space. Astronauts outside this protective bubble are at risk. According to European Space Agency, on a mission to Mars, they could receive radiation doses up to 700 times higher than on Earth. So before going, they have to solve these 4 problems. Hope you liked this episode. Don't forget to subscribe and share it with your friends. If you like it, then hit like and comment on it.